So, Petworld, awesome. Has exactly 14 animals. 3G, 3H, 3L, 5X. Now, it's not uncommon for people to write G and then like a little subscript 3, but I would suggest not doing that. Did anyone do that? It's okay if you did. It's normal.
I did it.
Okay. It's like confessional, right? Like, yeah, I did that. But I would do this because what we want to do is we want to see the game pieces that we're going to be dealing with so that we can visually kind of move them over to the board in our head, right? If you do G3, it becomes an abstraction. The other thing is that we can cross out variables as soon as we use them up, and then you can see how many pieces are left, okay? Small things, but it can make it a lot easier. Okay, it says that they're kept in 4 cages. This sounds like a grouping game because we have variables that are kept in cages. And so what I'm going to do is I'm going to put my 4 groups right here, and then I'm going to put things into these columns. And so that's why I consider grouping games vertically set up. Right? I'm putting my groups vertically, and if I do ordering, it's going to go left to right. Now there's no ordering in this game, but if we have a hybrid game, we can do that because it's all set up. Okay, each cage contains exactly 2, 4, or 6 animals. Let's stop right there. If each cage contains exactly 2, 4, or 6 animals, what do you know for sure right now about each of your cages?
No odds.
Okay, no odds. That's right. You're not going to have 3. You're not going to have 1.
I'm gonna have 0.
Wait, what?
No zeros.
No zeros. No, that's significant. No, that's actually a big deal. So what does that mean?
Every cage has to have at least 2.
At least 2. So I always want to write down what must be true. And right now I know W's got to have 2. I know X has got to have 2. I know Y's got to have 2. And I know Z has to have 2. Okay, now of course they have to have more than that because that's only 8 of our 14. But I would take a moment, and I did take a moment here to think about this. We have 14 variables. I have 8 of my slots written down. I know that those slots have to be filled. I don't want to put 2 more right here because although that could be true, as far as I know, that doesn't have to be true. And now I've made that mistake. So in the games, when you're writing stuff in your diagram, make sure that you're always writing down things that must be true. That said, I want to go as far as I can possibly go. So what I wrote on my page is I said, okay, wait, I got 8. It's a small thing. You don't have to write this down, but I just had to figure this out. So how many slots are left? 6. It's a simple thing. But how are those 6 slots going to be distributed? Yeah, go ahead.
In pairs.
They're going to be distributed in pairs. So really, how many things are we dealing with right now? How many slots?
3.
Technically 6, but 3, right? Because it's going to be 2, 2, and 2. So I actually just wrote this off to the side. I kind of noted, I was like, okay, I'm going to have this, 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 and this. And, you know, this block of 2 could go here, 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 here. This block of 2 could go underneath another block of 2, and so on. But what I'm doing is I'm making this visual, right? So I can see, okay, this is all that I've got left. I've got my 8 slots here, and I've got to have 6 more, and they're going to come in groups of 2. So that means I have 3 more things I have to worry about. There's not very much. In most games, when you think about the unknown or what you haven't written down, it feels like there's a lot of options. The reality is there's not that many. And here there's only 3 more things, right, that we have to worry about. Are we cool with that? Okay, so any cage containing a G also contains at least one H, and any cage containing an H also contains at least one G. All right, so what that means is if you have H, then you have G, and if you have G, then you have H. Double arrow, right? You gotta have at least one. Now, I could have an H and a G, and then I could have like another H, and we're good because, well, I would need something else. Maybe I'd have an S, right? But I would need, I've satisfied the condition. So at this point, I don't know what this means. I could have HG and then H and then something else. I mean, I know it's got to be an even number, but it just said at least one H. So, okay. Then it says the same thing for L and S. So I'm going to say, okay, if I have L, then I have to have S, and if I have S, then I have to have L. Okay. Then it says neither Y nor Z has G. The G is out here. And let's stop there for a second. That's a negative rule. We talked about negative rules, right? We want to try to turn them into positive rules. That's just because it's good for our emotional health, but it's good for the games. So if G can't go there, what do you know?
H can't go there.
H can't go there as well, right? Because H requires G.
So
W and
S
X has to
go
be.
there.
L and S have to go there, right? Because you have to have two. Can't be G or H. So we know we're going to have an LS here. And we know we have to have at least one of each because you can't just have one by itself, right? So now notice I'm going to come over here and I'm going to cross off two of my S's and two of my L's. So I only have one L left and three S's. Okay? Now, the last rule says W and X contains L or cannot contain L. So this has made this game a lot easier because if L can't go there, S can't go there. So that means I have to have a G and an H and a G and an H. Cool? So put G, H, G, H. And again, I'm going to cross off two of my G's, two of my H's. Let's talk about this. I'm actually going to split this game down the middle here because it feels to me like we're dealing with basically two, like the LS's go on this side and the GH's go on that side, right? Remember, we only have 6 more things that we have to worry about, and we have them right here. We have our GH, we have our L, we have our SSS, right? I can get rid of this so I have more space, but let's talk about this side first because this is easier. We have our GH, and we have one more GH. What do you know about that? Those remaining 2 variables.
Has to go in WX.
Has to go in WX. What else do we know about them?
They have to go together.
They have to go together because we can't do 3, right? We can't do like GH. I mean, because it's 2, 4, or 6, there's a lot of constraints here. So I don't know which side it's going to go to, but what I'm going to do is I'm going to write GH over here. I'm going to put a box around it because it's stuck together, and I'm going to do this arc. That's basically what it's going to do. It's going to go back and forth between those 2 groups. All right, now this is a little. So I'm done. I'm done with these G's and H's because now I have G and H in my diagram. I have LS and then SS. Can anyone tell me about these 4 variables? Anyone?
Don't they all have to be grouped together as well? Because you cannot have every cage must at least have one L.
Okay, so both these cages have at least one L. So that rule is taken care of.
You'll have to have an L and an S together, and you'll have to have 2 S's together.
Okay, why?
Because you have to have 4 or 6.
Yeah, you have to have 4 or 6, right? So like, if I try to, just focus in on the L for a second, right? If I try to put that L like here, I'm going to have to put an S with it to get to 4, right? If I put it here, I'm going to have to put an S with it to get to 4. So I have an LS, and that's together always, which means the remaining 2, I'm going to put a comma here, SS have to go together. Now, I put a comma there because I don't want to signal any sort of order or anything. The comma to me means I'm just listing this stuff out. So, how could these 2 boxes be arranged? Well, all of them could go in Y. All of them could go in Z because that's 6, right? Or back and forth between the 2. Any questions about that? Right, that's it. That's all our variables. I can cross them all out now. So we've taken care of everything. Let's go into the questions. Which one following could be a complete and accurate list of the animals kept in cages W and Y? So W and Y are these 2 cages right here. Could W, let's look at A, be GH? Sure. It could be GH by itself, right? And then this other GH would go there. And then Y would have to have at least LS. It says 2 lizards and 2 snakes. Could we have 2 lizards and 2 snakes in Y?
Yeah.
Yep. So if you're feeling confident about your setup, I would just pick this answer and move on. Okay, cool. 2. That's our next if question, or our first if question, I guess. If there are exactly 2 H in W, okay, if there's 2 H in W, that means this thing is now over here. And the number of gerbils and the number of G in X, the number of G in X, which is what right now?
1.
1, right? The number of G's in X is equal to the number of snakes in Y. Okay, if the number of snakes in Y is equal to 1, then what do you know?
S and S comes to moves over to Y.
Moves over to, oh, this moves over to Y?
Yeah.
Wait, hold on.
No, it's
So if the
only
number
one.
of gerbils in X, which is 1, right, is equal to the number of snakes in Y, I can only have 1 snake here, which means both of these boxes now have to go over to Z. We could draw this all out, but I'm hoping you can see this in your head. If you can, then you can just keep moving through these questions. Are you guys, everyone need me to draw this?
Can you just explain
So
it
D.
again?
Sure.
Yeah.
So the first clue says if there are exactly 2 hamsters in W. If there's 2 hamsters in W, what do you know over here?
There's 2 gerbils too.
Yes, there's 2 G's over here, right? And if the number of gerbils in X, which is, by the way, 1 at this point, is equal to the number of snakes in Y, okay, well then that means the number of snakes in Y has to be 1. And the only way to do that is to put all the other snakes over into Z. Then the number of snakes in Z must be 1, 2, 3, 4. Okay, that's the answer. So the answer is D. 3. If Z contains exactly twice as many lizards as Y. So if Z has twice as many lizards as Y, what do you know for sure? Okay, Y can only have 1, Z has 2, which means this box is going over here, right? What about this box? We don't know, right? We don't know where it goes. Okay. Which of mine can be true? Could Y contain exactly 2 lizards?
No.
No, it'd have to be 1. Could Y contain exactly 2 snakes?
No.
No, it could have how many? Could have 3 or just 1, right? But this block has to be over in Z. This is the only one that's like floating around. Okay? Y contains exactly 4 animals. Could Y have 4 animals?
Yes.
Yeah, the 2 S's could come over to Y, so that's the answer. Richard, feel good about that?
Yeah.
Okay, cool. 4. If the number of animals in W is equal to the number of animals in Z. If the number of animals in W is equal to the number of animals of Z, we could have 2 and 2 or 4 and 4, right? Then which of the following can be true? Cage W contains 6 animals. No, we just figured out it could be 2 and 2 or 4 and 4. Cage X contains 6. X can never have 6, right? It can only have 4 or 2. Y contains exactly 1 snake. Could Y have only 1 snake? No, because even if you do 4 and 4, you're still going to have to put one of these blocks over here with Y, which means Y would have, at a minimum, 2 snakes. You guys okay with that? Because Z, the most Z could have is 4, which means Y has to have 4, at least. So let's keep going. D, Y contains exactly 3 snakes. Could Y have 3 snakes?
Yes.
Could have this one right here and then these 2 right there, and now you have 3. That's totally fine, because then Z would have the LS, but that's 4. That's okay. Okay, so the answer is D. 5. If cage Y contains 6 animals. Okay, if Y has 6 animals, what do you know?
There's only LS and Z.
Yes, Z has only LS, right? Everything else is in Y. Which of the following must be true? Y contains, we don't know anything, or it's not Y, W. We don't know anything about W, so W doesn't have to have 2 gerbils. X contains 4 animals. Does X have to contain 4? Could, doesn't have to. Z contains 2 snakes. No, wait, hold on. Y has 6 animals? No, Z would only have 1 snake, right? Okay? The number of snakes in Y is equal to the number of lizards in Y. No, that's true for Z, but not for Y, because everything is in Y that can be. The number of snakes in Z is equal to the number of lizards in Z. Oh yeah, that's actually what we just said, and that is true because there's only these 2 things in Z, so 1 L and 1 S. Anyone confused? Okay, we're good. Okay. Last one. At most, how many snakes can occupy Y at one time? Oh, well, we just saw that all 6 of these could come over here into Y, and that would be 1, 2, 3, 4, 4 snakes, so the answer is D. Sound good? Okay, so there's a couple small things that can help you go quickly through this game. One of them is to write out the letters. Another one is is to figure out what must be true at a bare minimum, right? Like they said, every group had to have 2, 4, or 6. So then you say, okay, well, at a minimum they have to have 2. I know that must be true. You don't want to look at your groups and say, well, I don't know whether it's 2, 4, or 6, so I'm not going to write anything. Well, you know it has to be at least 2. The other thing is once you get those 8 in there, because you have 2, 2, 2, 2, then you say, okay, well, how many are left? It almost always feels like a lot, but it's not that many. There's only 6 left, and that meant 3 things. Three things of 2. And then finally, just try to push the inferences as far as you can by turning negative rules into positive rules. And then again, asking yourself what's left. Whenever you think you're done making inferences, ask yourself who's left and what do I know about them. In this case, we said, okay, well, we got these guys in there. Who's left? What do we know about them? Oh, well, we know the GH has to be together. In some games, you wouldn't necessarily know that. They could be floating around. But whatever you know, and you want to write that down. Any questions? Questions about games in general? Okay.